Welcome to Learning Intention 8, Rearranging Inequalities. In Learning Intention 7, we had a look at an introduction to inequalities. So what are they and what they represent? In this video, we're going to have a look at how we can manipulate said inequalities. So previously we'd had a look at how to rearrange equations. We're effectively going to apply the rules from rearranging equations to inequalities. Consider the two examples. 4z plus 10 equals 14 minus 2z, and 4x plus 10 is greater than or equal to 14 minus 2x. So what are the differences here? Well, namely, the one on the left is an equation. How do I know that? Well, it's got the equal sign between two expressions. And on the right, this is an inequality. Again, how do I know? Well, it's got that inequality sign. Now, what else is different about these two? It's 4z plus 10, and over here it's 4x plus 10, and 14 minus 2z, and 14 minus 2x. Well, they look almost identical, except this equation is, well, it's got z as its variable, and this inequality, it's got x as its variable, but aside from that, they're pretty much the same. So if I wanted to solve them, I want to rearrange it such that the variable is the subject of the equation and the inequality. Let's first have a look at how we do it with the equation. Well, I want to make z the subject. So firstly, I'm going to get rid of z on this right hand side. And to do that, I'm going to add 2z to both sides of the equation. So 14 minus 2z plus 2z. Then 4z plus 10 plus 2z. And that's going to give me 14. The negative 2z cancels out with the positive 2z. 2z plus 4z, that will be 6. 6z plus 10. Now, I want to isolate the z on the left, so I'm going to get rid of this constant of 10. To do that, I'm going to take 10 from both sides. So we'll say negative 10 plus 10 6z, 14, take 10. Then this positive 10, this negative 10, they're going to cancel out. So what I'm left with is 6z. And then on the right hand side, 14 take 10, that's going to be 4. And I want to know the value of z, so z, I can simply divide both sides of the equation by 6. Thus, z equals 4 divided by 6. Now, on the right hand side, 4x plus 10 is greater than or equal to 14 minus 2x. Well, I've already solved the equation model that looks very similar to this. So let's see if I can do all the same rules that I've done to the equation and do it to the inequality, and we'll see if it works out. So first, let's try and isolate the x. So put in the inequality symbol and we'll say 14 minus 2x, 4x plus 10, and we're going to add 2x to both sides of the inequality. Because what I do to one side, I must do to the other side to maintain balance. So once again, negative 2x plus 2x, that cancels. That will be 14. 2x plus 4x will be 6x plus 10. Now getting rid of this 10 because I want the x to be by itself. I'll say 14, 6x plus 10 Then we're going to take 10 from both sides of the equation, much like I did in the equation here. That will be 4. And then positive 10 plus negative 10, that is nothing. So I'm left with 6x is greater than or equal to 4. And to get rid of this coefficient of 6, I'll simply divide both sides of the equation by 6, or both sides of the inequality, I should say, by 6. Thus, x equals 4 divided by 6. So notice, both this equation and this inequality, they look really similar. The only difference is the naming of the variable and the operator that's been used. So over here it's an equation, so it's got the equal sign, and over here it's an inequality because it's got this greater than or equal to sign. So on the left here, z is equal to 4 over 6, where on the right, x is greater than or equal to 4 over 6. Let me try and graph this. I've got my ruler. We'll see if we can make this nice and neat. It's a line here. Draw a line here. It's not too bad, considering. So let's mark our points. So 4 over 6, that's going to be somewhere between 0 and 1. This will be 4 over 6, again somewhere between 0 and 1. Now graphing z equals 4 over 6, that's going to be right there. Graphing x is greater than or equal to 4 over 6. Well, I'm going to draw my open circle, shade it, because it's greater than or equal to, it touches this point, and then draw the arrow to the right. So thus we have solved this equation and this inequality, and we have graphed both of them. Not too bad. Going down, so what we know is we can use the same rules of equations to solve inequalities, but there are two things we need to keep in mind. So the direction that the inequality operator is pointing, that can change based on two scenarios. So the first one being, if we swap the expression around, or if we swap the expressions in the inequality around, the inequality symbol changes direction. So consider 1 is greater than x. If we grab this expression here, x, and move it to the left and move the 1 to the right, then we also have to flip the direction this inequality operator is facing. So 1 greater than x is the same as writing x is less than 1. So think about what that means, say it out to yourself, and then try and figure out whether that still makes sense. What would happen if we didn't flip the operator? Would this situation still hold up, or would it be a bit wonky? Now the second situation where the operator can flip is if we multiply both sides by a -1, or if we divide by a negative number. So in this case, -x is greater than 10. We're going to multiply both sides of the equation by a negative number, -1. Thus, -x will become x, and -10, or 10 will become -10. We can say x is less than -10. So on the top line we say -x is greater than 10. On the bottom we say x is less than -10. Going over to the right, in a similar situation, -2z is less than 10. Dividing both sides of the equation by -2, which was the coefficient of this z, we can say that should be a z. Z is greater than -5. So originally it was -2z is less than 10. Z is greater than -5. So let's have a look at that in practice. So -2x plus 5 is greater than 11. let's try solving that. So firstly, we need to get rid of the 5. We want to have the variable x by itself. So I'm going to take 5 from both sides. So that will be simply negative 2x. My apologies. Negative 2x. 11 minus 5. So I didn't write it down, but I took negative 5 from both sides of this inequality. Evaluating the expression to the right, I've got 11 minus 5. What's that going to be? Well, that's going to be 6. Negative 2x is greater than 6. Dividing both sides of the equation by negative 2. Flip the sign. So rather than greater than, it's going to become less than. Negative 2. 6 divided by 2 is 3, so x is less than negative 3. Down here, x over 3 plus 1 is greater than 4. Again, I'm going to solve that by isolating the x. So I'm going to take 1 from both sides of this equation. That will become x over 3. 4 take 1 will be 3. Then to get rid of this coefficient of 3, I'm simply going to multiply both sides of the inequality by 3. So x will become 3 times 3. Thus x equals 9, or x is greater than 9. Going over to C, 8 is greater than or equal to 3a minus 2. Notice that the variable is now on the left-hand side of this inequality. What we're going to do is, firstly, we're going to flip this inequality around. So, alright, 3a minus 2 is less than or equal to 8. As originally 8 was greater than or equal to. Now this expression is less than or equal to this expression. Then we're going to isolate the a. First we get rid of the constant, so we're going to add 2 to both sides of the inequality. That will become 10. This will become 3a. And then to get a by itself, we'll divide both sides of the inequality by the coefficient here, which is 3. So it will become 10 divided by 3. Therefore, a is less than or equal to 10 divided by 3. Going down to D, it's getting a little bit more complicated. 3 minus 2x over 5 is less than 4. What are we going to do? Well, we're going to get rid of this constant here. It's a positive 3. How do we get rid of a positive 3? We give it a negative 3. So taking negative 3 from both sides of the equation, on the right hand side we're left with 1. On the left hand side, 2x over 5. Getting rid of this fraction, we're going to multiply both sides of the equation by 5, or both sides of the inequality, I should say, by 5. So that will be 5. This will be negative 2x. And getting rid of the coefficient of negative 2x, we're going to divide both sides of the inequality by 2x. Thus x equals 5 over negative 2. Thus, x equals 5 over negative 2. Now, graphing these, let's have a go at graphing once again. I'll do them both down here. Nope, rule is not going to work. So let's say that's one. Here's the other one. So for A and B, x is negative 3, so we'll say negative 3 is here. This will be negative 2. Oops. Negative 2. This is negative 4. Now the inequality says x is less than negative 3. So open circle, I won't fill it because it doesn't touch negative 3. It starts at negative 3. And it says less than, so x is equal to all of the values to the left of negative 3. Over down in B, we have x is greater than 9. So 9, 10, and 8. And x is greater than 9, so again, open circle around 9, then pointing to the right because x is equal to all of these values above negative 9. Going over to C, I'll graph it just here. 1, 2, and 3. 10 over 3. And we'll say this one will be 0, and we'll make this one 10 over 3. That's roughly 3.1, I believe. So we'll just say 4. Now, graphing that, A is less than or equal to 10 over 3. Draw an open circle over the 10 over 3, fill it in, and then point to the left. Thus, that is now graphed. And finally, one, 2, and 3. 5 over negative 2, that's going to be negative 2.5 roughly. So let's say negative 3 and negative 2. Drawing the open circle, and it's going to the left. X is less than 5 over negative 2. Thus, we have solved these linear inequalities and we have graphed them.